Yes, right. Today our topic is to learn about the second order differential equations today. Yeah. Second order differential equations, right? Okay. When you are considering a second order differential equation today, um, like it's a power 2, like in a second differentiation equation, we should be able to solve uh, that kind of situations. That is what you mean by the differential equation. Usually, the format what you come across over here is that if you get the second order differential equation, there are two part of a solutions we can see. So it's a the solution over here is it's a combination of two facts. The first one is that is called the general solution. General solution. Yeah. Then initial part of it, we have to find the general solution. Then we have to work out with the particular integral. The second part is called the particular integrals. Particular integral, right? Then initially, how do we supposed to simplify? Yeah. So basically, the format, if you discuss about the format of a differential equation, is this one, just like this. A, some constant time of dy by dx plus b dy by dx plus c is equals to 0. If this is in this format today, we call this is a homogeneous differential equation. The homogeneous differential equation today. So if it comes with this kind of format, just like the same format with that, a d squared y by dx squared, or which is dx squared, plus b dy by dx plus c is equals to another function fx or something. That is called the non-homogeneous differential equations apart. Not, it's not equals to 0, it's come up to another function. This is called the non-homogeneous differential equations, right? Okay. Those are the facts you have to understand about homogeneous differential equations and the non-homogeneous differential equations. So anyway, let's see how to solve. Initially start with the homogeneous differential equations and see whether how to do it. After it will come up with the non-homogeneous differential equations. So this is come up with homogeneous differential equations, right? Okay. If you come up with this homogeneous differential equation today, let's see how to do this kind of a situation, right? Then initially that homogeneous differential equation is just like this today, right? We will get one example and show you how to do this kind of a function today. Okay. So initially, if you get an equation somewhere like this today, 2 d squared y by dx squared plus 5 dy by dx plus 3y is equals to 0. So initially, we will consider this y as e to the power mx. We'll consider this y as e to the power mx. Then we can say dy by dx become m e to the power mx. Just do the differentiation. Second differentiation, you can say m squared e to the power mx. Right. Then if you substitute over here, what you get in this fraction is turned up to 2 m squared e to the power mx plus 5m e to the power mx plus 3 e to the power mx is equals to 0. So with that you can take e to the power mx out. So that is turned up to 2m squared plus 5m plus 3 is equals to 0. Right. Then what you can get here is, we know that e to the power mx is not equals to 0, because we know that exponential function, it never turns into 0, because if you draw the exponential function just like this, it come up to 0 but it never turn up to 0. So therefore what you can write, 2m squared plus 5m plus 3 is equals to 0. If you simplify this, you get the answer m equals to minus 3 over 2, minus 3 over 2, and m is equals to minus 1. Anyway, this equation we call as the auxiliary equation. This equation we call as the auxiliary equation. Auxiliary equation, right? Then, then today we just get this m as the solutions for m become y equals to e to the power minus 2x. Right? Then you can say this is y equals to this equation. What you obtain here is one solution is e to the power minus 3x, and sorry, m is minus 3 over 2, and other one is y equals to minus 1. Therefore, the solution you can write in this format of it. A times of e to the power minus 3 over 2x plus b times of e to the power, this is both are minus, both are minus, to the power minus x. That's a way of writing the answer for this, right? Okay. Then you can write the final answer in this format. That's a way of getting this answer. Okay. So that is the what do you call that, general solution of this. Since it's a homogeneous equation, this is a general solution of this differential equation. So this one is the general solution. Later on we'll come up with the particular integral. General solution. Then so for a homogeneous equation, you get only a general solution. Get a general solution. That's fact. You have to understand that. Okay. Let's go ahead with another example and try to understand this situation. Right. Yes. Then if you come up with a question somewhere like this, the second example what they have given is d squared y by dx squared minus 6 dy by dx plus 9y. is equals to 0. Right. Then over here, Pate, this is a second type of it. Then if you get the fact y equals to e to the power mx, so you can say dy by dx equals to m e to the power mx, d squared y by dx squared is equals to m squared e to the power mx, right? So this is turned up to m squared e to the power mx minus 6m e to the power mx plus 9 e to the power mx is equals to 0, right? Okay. Then if you take e to the power mx out, m squared minus 6m plus 9 is equals to 0. So with that you can say m squared minus 6m plus 9 is equals to 0 because e to the power mx is not equals to 0. So this is the auxiliary equation. Then yeah, if you simplify this, you can understand that here, this is m minus 3 whole thing squared is equals to 0. So it is turned up to m is equals to 3. M is equals to 3. So yeah, m is equals to 3. So if you get a one solution for this Pute, it's just an identity. This is called overlapping solution. So in this situation, you can write the answer for y is equals to a plus bx types of e to the power 3x. You can write the answer in this format for that kind of a solution. Yeah. So it has only one solution, right? Okay. If you have two solutions, you can say, later on, I'll just summarize this fact. So with that, you can get the answer a little bit later on. Right. Okay. Then let's come to the fourth type of the question. This is, we are talking about example 3. This is example 3 in the this book. Just write it here. Example 3. This is the second example we are discussing about. This was the second example. Example 2. This is example 3. And the other one is with example 4. Yeah. If you come up with this example 4, Pute. Right. Yeah. That is also the same type of it. Just, yeah. I mean, just if you work out it, d squared y by dx squared plus 8 dy by dx plus 16y equals to 0. To make it up, if you work out with this one, the auxiliary equation, it will become m squared plus 8m plus 16 is equals to 0. This is auxiliary equation for this. So this is turned up to m plus 4 all things squared equals to 0. So that is m is equals to minus 4. So with that, you can write the answer. This is just a one solution. So you can say y equals to a plus bx to the power bx e to the power minus 4x is the answer for that. Right. Okay. Yes. Now let's come up with the next situation. That is the fourth type of it. Example 5. So that is the equation is d squared y by dx squared minus 6 dy by dx plus 34. Then for the same technique, if you use it, the auxiliary equation become m squared minus 6m plus 34 is equals to 0. So if you can work out, m is equals to minus 6 plus or minus square root of minus 6 squared minus 4 times of 1 into 34 divided by 2 into 1. So with that, m is equals to, you get the answer with a 3 plus 5 is a one solution. Other one is m is equals to 3 minus 5i with it. Right. So if you, the general solution, if you work out over here, you can say like this. So I just, if you work out the rest of it, it's turn up to y equals to a times of e to the power 3 plus 5ix plus b times of e to the power 3 minus 5ix is the answer for that. Then if you work out with this, you can say this is a e to the power 3x plus, sorry, into e to the power 5ix plus b times of e to the power 3x times of e to the power minus 5ix. That's how it comes. Then from both of them, you can say e to the power 3x out. Then what is the remaining answer? A times of e to the power 5ix plus b times of e to the power minus 5ix. Then in our further, what we call that complex numbers, we have already learned there is a fact e to the power ix. You can write, how do you get it? You get cos x plus I sin x. We already learned this kind of a situation. Sorry, if I just get just a small modification with this. If this is this way, ikx. So this is turn up to kx and this is turn up to kx. So with that, you can write, so this is the exceptional theory we have already learned in our the complex numbers. I hope you can remember this. So using this formula, this part of a formula, we can do a small alteration in this equation. That is like this. Right. So over here, the reduction over here is e to the power 3x came over here, y equals to e to the power 3x came over here. So this one you can say a cos 5x plus I sin 5x plus b cos minus 5x plus I sin minus 5x. Right. So with this, if you simplify this, you can say this is y e to the power 3x. So this is a cos 5x plus ai sin 5x plus b cos 5x, because you know that minus cos x and plus cos x are same, minus b I sin 5x. Sin minus theta is equals to minus sin theta. So then you can write y equals to e to the power 3x. So cos में देखा, if you simplify this, this is turn up to a plus b cos 5x plus a minus b sin 5x. So with that, finally, you can just, because these are still a and b is not decided over here. So there you can say e to the power 3x times of p cos x plus q sin x. That's the answer for this. Is that clear, Pate?
Yes, sir.
That's right. Okay, let's go to the some example and try to understand. But in this case, right, in auxiliary equation, In auxiliary equation, there are three types of equation. Auxiliary equation means a x squared plus bx plus c equals to c format of it. You get three types of solutions you can expect today. First one is two solutions. Two solutions. For this case, you can write a e to the power ax plus b e to the power bx. One solution. That situation you can write a plus bx e to the power kx, right? No solutions. No solutions means actually no real solutions. If you don't have the real solutions, you can write the answer this format. Then make up, if you minimize this, you can say a cos kx plus b sine kx. So simply you can write this answer in this format. Later on, we'll try to understand how do you make it. So these are the options where we have to follow up when you do this second order differential equation. This is the general solutions of this uh, differential equations, which is if it is for the homogeneous equation, right? If it is a homogeneous equation, you get general solution only, but when you come up with the non-homogeneous equation, apart from the general solutions, there should be another particular integral should be added to this question. Let's try to understand those in the next lesson today, right? Okay. Yeah, let's try to go ahead with some examples and try to make sure how to do this kind of a question, right? Yeah, then we'll come up with some example. Yeah, I'll start with the new page. Yeah, in this new question today they have given here is this is example 6a, question number 1, part A. The fraction is d squared y by dx squared plus 5 dy by dx plus 6y is equals to 0. That you can say the auxiliary equation. Auxiliary equation you can say m squared plus 5m plus 6. The base for forming this differential equation is this one. Already here we have to get y equals to e to the power mx, and by making it only you get this answer. Right over here you can understand from this, just go through these things, then you can understand that yes, it's come with this equation today, right? Okay, then if you solve this, what are the answers you get today? You get m is equals to -2 and m is equals to -3. Therefore, you can write the general solution for this much. General solution, you can say y equals to a e to the power -2x plus b e to the power -3x. That is the general solution for this differential equation. So simply you can get these general solutions for this differential, this kind of differential equations, right? Okay. Yeah, right. Then let's go to the other few more questions with it, right? Okay. Then if you just do the question number, we'll go ahead with yeah, I'll go ahead with the question number C. Here they have given d squared y by dx squared plus 2 dy by dx minus 15y equals to 0. So the auxiliary equation turn up into m squared plus 2m minus 15 is equals to 0. So this is turned up to m plus 5 m minus 3 is equals to 0. So with that you can say m equals to -5 and m is equals to 3. So if you get the answers for this is turned up to y equals to a e to the power -5x plus b e to the power 3x would be the final answer for this. That is how you need to do this kind of situation, Yeah, I'll come up with another example. Yes, E, that is d squared y by dx squared plus 5 dy by dx is equals to 0. So over here, this is turned up to m squared plus 5m is equals to 0. So with that, you can say m is equals to minus 5 and m is equals to 0. So you can write y equals to a e to the power minus 5x plus b e to the power 0x. So that is just turned up to y equals to a e to the power minus 5x plus b is the answer for that. That's a way of getting the answer for this. Right.
So then when will we get the a plus bx e to the power x format?
Apate, sorry.
The other format, the in within brackets a plus bx?
Yeah, that is come if you have a one solution, Pate. So this is a situation method. Yes, that's a very good question you ask. Right. So there are three types of auxiliary solutions we come across, Pate. The first option is if you get two solutions. If you get two solutions, we can put this equation. Right. If you get only that here, Pate, you maybe misunderstand whether this is one solution. No. Here you have two solutions, but in this equation, you get two answers. No. Understood? If you get two answers, you should write the format in this format. A e to the power minus 5x plus b e to the power 0x. That's the format we write. Is that clear?
Yes, sir, got it.
Yeah, right. Okay. Then let's go to the type where you ask. Yes. Let's come up to the question number 2. The same exercise I'm referring to. Question number 2, part A. So that is d squared y by dx squared plus 10 dy by dx plus 25y is equals to 0. So here the auxiliary equation become m squared plus 10m plus 25 is equals to 0. So in that case, you can say m plus 5 whole thing square. There, how many solutions you get with it? You get only one solution. M equals to minus 5. Therefore, you can write here the solution is general solution for this a plus bx times of e to the power minus 5x would be the solution for this. Is that clear, Pate?
Yes, sir.
Yeah, right. Okay, let's go ahead with another example. Right. If you do question number C, that is d squared y by dx squared plus 2 dy by dx plus y is equals to 0. So if you get the auxiliary equation, it's turn up to m squared plus 2m plus 1 is equals to 0. So that is m plus 1 squared is equals to 0. That is m is equals to minus 1. So you can write y equals to a plus bx times of e to the power minus x. That's the answer for this. I think it's clear with you how to get the fact. Right. Okay. Right. Then let's come up with the answers for this. Okay. Then if you question number 3. Question number 3 is related with the third type of it. If you get no real solution situation, how are you supposed to do this kind of a question, right? So initially, if you come up with, I'll just come up with E today. E because later on we come up with the part, the other parts, d squared y by dx squared plus 8 dy by dx plus 17y equals to 0. So with this case, if you simplify the auxiliary equation, turn up into m squared plus 8m plus 17 is equals to 0. So therefore, m is equals to minus 8 plus or minus b squared. B squared is 8 squared is 64 minus 4 into 1 into 17 divided by 2a. 2 into 1. So it's turned up to m is equals to. So if you just simplify this, so over here, so this is, if you simplify this quadratic, it's 1, 8, 10. 70. So you get the answer minus 4 plus I. Other one is m equals to minus 4 minus I. So if you write the answer, there are two solutions. So you can write this is y equals to a e to the power minus 4x minus, sorry, minus 4 plus I x plus b times of e to the power minus 4 minus ix. Right. So that is the answer where you get. So from this equation, you can write y equals to, this is a real part is this. So you can say e to the power minus 4x out. And for the other part of it, e to the power ix is the answer for that. Right. Therefore, you can write this is the number in front of you is 1. Therefore, straightforward, I can write this answer this format. Cos x plus I sin x scale, because here the coefficient is 1. That is the reason where you need to write it. Hope you can understand. If it is that clear, Makshan?
Yes, sir.
Yes, right. Okay. Let's go to another example and try to verify this concept. If it is a question somewhere like this. Uh, if you come up with f, f. If you come up with f, the answer is d squared y by dx squared minus 4 dy by dx plus 5y is equals to 0. So this is auxiliary equation. We have m squared minus 4m plus 5 is equals to 0. So here you get the answers. M is equals to 2 plus I, 2 plus I, another one is 2 minus I. Here with a straightforward, I can write the answer in this format. Then you can write y equals to, the real part is 2. So straightforward, you can write e to the power 2x. Plus here the coefficient is 1. Therefore, it's not addition, it's multiplication. Cos 1x plus I sin 1x. So you can write the answer for f in that format. So here just a small mistake with it. This is not I is not there. There is no I. It's not a. He also same. No I. So cos x plus I sin x. So straightforward, you can write the formatting that way. Right. Okay. Let's go to another example. Yeah. So if you come up with G, G, that is d squared y by dx squared plus 20 dy by dx plus 109 y equals to 0. So the auxiliary equation turn up into m squared plus 20m plus 109 equals to 0. So with that, you get the answers. M is equals to 10 plus 3. I put it. This is minus 10 plus 3i is a one solution. Other solution is minus 10 minus 3i. So the real part is minus 10. So you can write y equals to e to the power minus 10x. And the complex part is 3i. Therefore, you can write this is cos 3x plus sine 3x. So this is plus. That's the answer where you need to write. Yeah. Now I think hope you understood how to do this question. Then I'll come up with the part A, just like different kind of factor which turn up to d squared y by dx squared plus 25y equals to 0. So if you come up with the auxiliary equation for this, so you get m squared plus 25m. Sorry, 25, just m, just so you can say m is equals to plus 5i and m is equals to minus 5i. Therefore there is no real component, therefore straightforward you can write y equals to cos 5x plus sine 5x. So you have to put a constants in front of it. I just forget it here. None of the questions, just I put a constants. There should be constants. I didn't put any constant over here, so that is wrong. So here I'll just do the correction over here with a different color. There should be a constant. There should be A, and this is B, and here also you can put A and B. These are arbitrary ones, but then you have to find them later. Later on, we learn how to find this A and B. Over here, that one also A and B. Just A and B. There should be a and there should be a B over here. There should be a plus. Okay. So that is a way of doing this kind of situations in this as a general solutions of this differential equation. Right. Okay. Then question number 4, also the same thing. Right. Then if you come up with a question number 5 with it, it's kind of a different question, not different question, the same concept we are referring to. Right. The 5th question, they have given us d squared x over d squared y over dx squared plus 2k dy by dx plus 9x is equals to 0, right? Where k is a real constant, find the general solution of the differential equation when modulus of k is greater than 3. Right, let's go ahead with this. So the general solution here is m squared minus 2km plus 9 is equals to 0, right? Then Pute, like if you check with this Pute, so yeah, you can get this answer. So m is equals to minus 2k plus or minus b squared. B squared is 4k, 4 squared minus 4a. A is 1 and c is 9. Divide by 2a. 2 into 1. So m is turned out to be minus 2k plus or minus the square root of it. So you can take 4 out. But if you take 4 out, it's k squared minus 9 divided by 2. Right. With this, you can say m is equals to minus 2k plus or minus 2 times of, here this is k squared minus 9 divided by 2. So if you simplify with 2, you get the answer minus k plus or minus square root of k squared minus 9 divided by 2. The two terms get cancelled, right? Okay. Then the first situation. Yes. The first part of it, what they say is, if modulus of k is greater than 3, that is, greater than 3. Let's see, greater than 3. If this is modulus of k is greater than 3, mean this k squared should be greater than 9. That means, what you can understand is that k squared is greater than 9. That means you have two solutions. Two solutions. What are the two solutions you get? M is equals to minus k plus square root of k squared minus 9. Other solution is m is equals to minus k minus square root of k squared minus 9, right? Okay, these are the two solutions where you get m. With that, you can write the first type of it, that is this type of equation. I'll just come up with this. That is this type of equation, this type of situation, this type of situation. So with that, you can write this is y equals to a e to the power minus k plus k squared minus 9 squared plus b e to the power minus k minus square root of k squared minus 9x. That's the answer for that. So simply you can write the answer in this format. 1 second. Yeah, that's it. Then the next situation today. Part 2, the same question, that is modulus of k is less than 3. That means today k squared is less than 9. That means you can say no real solutions. No real solution situation. So over here, the solutions for m become minus k plus or minus I times of square root of k squared minus 9. So that answer is a negative. So you don't have the real solutions for that kind of a question. That means this the term inside the square root become a complex number. That is the fact where we need to understand from this question today. Hope you can understand what I'm saying. Is that clear, Pute, what I'm just mentioned?
Yes, sir. Got it.
Yes, right. Okay. So there's a small thing. We need to concentrate on this. So suppose that today, like this is not k squared minus 9. This is the fact we to understand. So over here, I will just different color to explain this situation. Right. If the square root of minus 4 pute, how do you write it? This is, you can write I square root of 4. That is turn up to 2i pute. If you get the minus 9, how do you get it with it? That is I 9, that is equals to 3i with it, right? Then if it is minus k, how do you write it with it? This is I square root of k. That's the answer where we write with it. So therefore, when you take this I out, obviously what happened to this term with it? This is not k squared minus 9 because you take a minus out of this fraction. So this is not the answer. So the exact format here would be m equals to minus k plus I times of square root of 9 minus k squared, because you take that minus out as the square root for I square root of minus 1 as I. So this is the answer for that. With that, you can write the real part is this one, this of it, plus or minus. So the real part
Sir,
you
but
can,
if we take the solution as minus I, then we can keep it as k squared minus 9, no?
yeah, k squared minus 9, yeah. Is that clear for it?
Yes, sir. Got it.
Yeah, right, okay. Then anyway, Mithana, the value what you gain here is, just if I explain this, this is minus k plus or minus square root of minus 1. If you take it out, this one should be 9 minus k squared. Then this part only we write it as I. This is I, the square root of 9 minus k squared. That's a way of getting this answer, right? Okay. Then from here, you can say this is a real part of it. This is a real part of it. This part of it. Therefore, you can say this is y equals to e to the power minus kx. A times of e to the power, sorry, not e. This is turn up to cos 9 minus k squared plus b sine 9 minus k squared. This is the answer for that. That's a way of getting this answer for this question. Hope you can understand how to do that kind of situation. Is that clear, Patel?
Yes. Yes.
Right, okay. Then like that, you can do these questions and you can finish this exercise. Yeah, you can finish this exercise 6A.